Okay, thanks for telling me I got off mute. Okay, so we got. Okay, how many molecules of water are in 240 grams of water? Okay, you can write the 2.40 times 10 squared as 240. I know a lot of you was doing that. 240 is less awkward, in my opinion, as well, than the 2.4 times 10 to the, but either way will work. Doesn't matter. Just a matter of, okay, so it's water. So that's, if in doubt, convert to moles. So this is going to be a two-step problem. All right, we're in moles now. Now we need to go to molecules. Now, whenever we see how many, that's the clue to go to Avogadro's number.
Isn't it molecules also? See molecules with the avocado.
It's anything. It could be sheep.
Oh,
It's like dozen.
Oh.
Dozen apples, dozen, So in this case, it's molecules. Okay, so everything cancels, leaving us molecules. And 3 sig figs. Okay, now we have gaseous water. So we're going to use a conversion factor 22.4 liters per mole. Okay, given cancels. And then we need to go to 22.4. Mole cancels. So we're left with liters.
test,
Yeah,
on the test, would you also like us to write down significant figures and state it?
No.
No.
no, that's only as some clarification needed. You put it down if you want though, it's fine. I just said it's not required.
Also, before we get there, do we use Avocado's number for atoms as well as molecules?
Yeah. It's just a counting number. It's like dozen can apply to eggs, pumpkins, sheep, it doesn't matter. So it's just when you say mole, that's the counting number.
Okay.
So atoms, molecules, particles. In physics, you're talking about moles of electrons, for example. They talk about electrical fields and stuff. So it's a very common unit in science. Okay, how many atoms? Now, the key in this one is how many atoms? And you notice it went from 6 points to 8 points. That means it's more involved because there's more points there. So 22. Okay, so we need to figure out molecules of water first before we go to atoms of hydrogen. So we're going to go through the same old conversions. Now we need to go to molecules.
Hey, Professor.
Yeah.
This is where I keep not figuring out this. So I have on my notes, if I turn mole to molecules, I put Avogadro's number on top
Correct, because the moles have got to cancel,
because the mole's got to cancel,
like right here.
like right there. But then everywhere before, I've noticed in the other questions, I'm going from apparently grams to moles of molecules. And I also put 1 mole over 18.02. But then the next train,
Go back,
as I call it.
go
I
back
put-
up to problem 4,
Right, I put. Yeah, you see, you put Avogadro's number on bottom.
because it's got to cancel because you're starting with molecules. The molecules, remember, always cancel the given. So if molecules are given, it's got the next term in there, it's got to have them on the bottom, otherwise it won't cancel.
So number 4 started with molecules first.
That's why we have to cancel molecules.
Gotcha.
That's why the molecules are on the bottom. If they're on the top, it would be molecule squared.
That's where the Dodgers can become the
Yes,
place,
sometimes
like
it
you just
also-
put it wherever to cancel out.
Exactly. It's just like any of the units. You put it where it needs to be to cancel. That's a really good way to put it.
So when you multiply water, or you divide water by its molar mass, that becomes a molecule.
It becomes a mole. And then from the mole, we get molecules.
Gotcha, you multiply it to become. Because it's a, I see. So when it's,
It just says cancellation bit.
when it's a mole, I'm gonna multiply it. When it's a molecule, I'm gonna divide it. Okay.
Okay, okay, we're not done yet. And now we have molecules of water. We want hydrogen atoms. So we need another conversion factor as to how many hydrogen atoms are in one molecule of water. It's a 2-to-1 ratio. So we need 2 atoms on top. And to cancel the molecules, we need 1 molecule on the bottom. And now we have atoms. Okay. Balance this equation. Okay, so we have hexane solvent, C6H 14 in oxygen, and we're gonna burn it. It produces water and CO2. Okay, so we have, this is a CHO. And right away, we see we have 6 carbons here. Let's just make 6 here automatically. So we have 6. Okay, hydrogens, we got 14 on the left. And we've got 2 on the right. 2 oxygens and 12, 13 oxygens on the right. Okay, so obviously it's not balanced. Where do you want to start? Hmm? What? Who's talking?
H.
H, okay. All right, so we've got to deal with that. So we're gonna put 7 here. That'll give us 14. It's gonna change the oxygens though. So we've got 7 and 12 is 19. Okay, oxygens are way underbalanced. So how do we make O2s 19? Gonna be what? Yeah, it's gonna be a fraction, right? Because we have odd and even, they don't match very well. So I'm gonna use fractions. So whenever you get in this situation, where we have, some odd equals even, think fractions. And then we clear the fractions afterwards. Okay, so that's gonna be 19 twos. And the reason why it's 19 is because the twos cancel, leaves us with 19. So now it's balanced. But there's a fraction present, so we have to clear the fraction. So that's the easiest way is if you look at the denominator of the fraction, which is 2, multiply everything by that. So that's 2, 19, 14, 12. Okay. Now a hint, if this, you're in a combustion problem, if this is even, you're gonna need a fraction. So C4, C2, C6, C8, C10.
Just for the carbons? Or could it be any?
No, it just for, yeah. And frequently they give you this even because this becomes a fraction, you have to deal with it. So just, if it's even burning, in other words, we're burning this with oxygen, think fraction when you get down to the oxygens. Yeah.
I do this totally different. I don't do the division. I usually just go a long route adding to both sides. If I end up getting it balanced, but there's larger numbers on both sides, does that still work?
Yes and no. The reason why it works is because the reason why we balance the equation is for stoichiometry. That's a middle step. And that middle step is a fraction. So. Yeah, as long as it's balanced. Bottom line, I don't care if it's got a factor of 2 in there or not.
Yeah.
Still balanced. Because the way we're using it is in a ratio. Some people don't like fractions. They'll say, I'll start over. And they'll go to the most complicated molecule and double it. And then work it through.
But one way or another, you'll find if.
Right. It's, because the goal is to balance the equation. Yeah,
Can we use the calculator?
so use this. If you remember how to do it, sure. Because the goal is to balance. Use the matrix method. Oh, one other thing, make sure your take-home problem is done and you bring it with you, because you gotta staple it to the back of your tests. And if you want to, if you're doing the extra credit balancing, bring that in as well. Okay? And if the problem with not bringing in your take-home problem, it's worth 20 points. Okay, so,
What's
it's just a hard equation to balance.
Is it under that take home problem?
It's in the same category. You go to miscellaneous, it's there, right? Okay, why do we balance the equation? Why do we go through all this work to balance the equation? It's two bits of information because it's a molar. It's a molar relationship, and number two, it's a molecular relationship. It is not a mass relationship. Okay, this is the way you make iron. You start with rusts. And you add carbon monoxide. In this giant iron hole. And some of them are as big as this room. Huge amounts. During World War II, they were making ships every 2 days. Liberty ships were going off the line. Liberty ships are made out of iron, so they were using tons of iron. Probably megatons of iron. Okay, so is it balanced? No, it's not. We need more room. Let's go.
That's all I understood.
Okay, so first of all, we're gonna immediately look at what carbons are fine. Oxygens always seem to be a problem. So notice over here, oxygen is in two places. Over here, it's in one place. On the left are two odds. On the right are evens. Now, there's only one way to convert an odd number to an even number. That's to multiply it by 2 or 4 or 6, some even number like that. All right. So this is in groupings of 4. So let's try not to mess with the iron. We're only going to mess with the carbon monoxide. All right, so if we start with 2 here, The problem with that is we have two O's and three O's, that's five, that's an odd number, so that's not gonna work. Then it must mean we need an odd number. Well, let's try three. Okay, that's three O's and three O's is six. That's an even number. So let's go with three. Okay, so that means three here. And we have three and three is six. Okay, so if we put three here for both the carbons and the oxygens, okay, the oxygens become six, carbons become three. Iron's left over. Okay, so it's 3, 1, 3, 2. Okay. Now we're going to need that ratio because we're doing stoichiometry over here. So we're starting with two givens. We're not starting with two givens, there's two different molecules. Okay, we're working with iron and carbon monoxide. That means that's stoichiometry then. Okay, and what we're going to do is we're going to start what's given. And that's CO. First step is convert to moles, because remember, balanced equations is a molar relationship. Next, we're going to use the balanced equation ratio.
So on mine, I did it by 28.01. That first step.
Oh, that's water, yes.
Although don't confuse me before tomorrow.
Ferguson, that roach did its job. What did you get?
28.01.
Okay. I'm so used to using water for everything. Okay, now we need to go to the balanced ratio from the balanced equation. So we're looking at iron and carbon monoxide. Okay, so here's iron, 2, carbon monoxide is a 3. Now, 3's got to go on the bottom because we have to cancel that, otherwise it won't cancel. Okay, that's the middle step. It's always there when you're doing stoichiometry, the ratio from the balanced equation. And then iron is, Misty, what did you get for iron?
55.85 or, yeah, 55.85 grams.
Okay, there you go. So moles cancel, CO cancels. Now, some people put 2 moles Fe, 3 moles CO. That works fine too. I don't put it, the reason why I don't put it, because in 1964, when I learned chemistry, we didn't put it that way. It doesn't matter, so I've been using it ever since.
And it's from. Mhm. It would be simply. Mhm. And you understand how I don't need some. Mhm. Mhm.
Yeah,
So I you were saying before, when we were balancing equations, if I come up with a big number, but I still put that in. So
Oh,
you
yeah.
have- you see how you have two-
What numbers did you get?
No, I'm just saying hypothetically, because you said that was.
Oh, yeah,
I got
yeah.
the same.
Let's say you had 6, 2, 6, 4.
Okay.
You still just,
Still put stick.
yeah, just go with your balanced equation. Because it won't matter, because, 2/4 is equal to 1/2. I mean,
Okay, yeah.
I did get that number. Yeah, I didn't get that.
Cause ours is.
It's 45.2.
45.2.
all right, wait a minute, let me redo it. Um, yeah, I see what happened. Somehow 4 got stuck in there instead of 34.
My calculator has got a lot too. That's not my.
Okay, did you get 4.5, 45.1?
I remember the 45. I don't remember what the full answer was.
It's 4.50510.
Might have been.
So the 5 makes a 0, 1. Had you put that, yeah, 45.1. If you have a TI 83, 84, 89, and the screen goes blank and you turn it on and you start typing before the screen is initialized, it'll skip the first character.
Yeah, that's what I
It's-
have. So I think that might be what's going on, because sometimes too, like when we're doing math problems, he's like, you got it wrong. I'm like, oh, I have to slow down on this thing.
It's, the only place you have to slow down is when when the screen is blank and it comes back on, just let it settle down. Then you
Yeah.
can go as fast as you want.
Yeah. Cause it's.
Okay, so that's it basically in the quantitative part. Yeah.
Pretty big.
Well, my answer is 45.05.
45.
Huh, yeah, I just rechecked mine. Mine's 45.05. And you got 45 what?
0.15.
45.
45. 45.195, yeah.
Okay, I'm gonna look at your tests, and if your setup is right and you're off by 1 sig fig in the back, you're fine. Because sometimes, like when you put in molar mass, it depends on what periodic table you use. Some are off a tiny bit. So according to my calculator, and this is why I'm coughing, because my nose is running. Which is fine when I'm up, not in the middle of the night.
Would be perfect.
Okay, all right. We have a chemical reaction. What kind of chemical reaction is it? Is this a salt or metal? It is a salt because it's got 2 parts. Because a metal would have 1 part. What about that? Also 2 parts, so salts. So 2 salts means double replacement. Okay, so that means these swap places. So we're gonna have K NO3. And that's, we need to determine whether it's aqueous or S. Plus, same with this, aqueous or solid. So we're gonna use our table. So we're gonna look at sodium nitrate, white. Then we have chloride and mercury, black. So the mercuric chloride is going to be a solid. The sodium nitrate will be solution. Okay, so is it balanced? Yes. So that means this is AQ and this is S. All right, so molecular equation is this, or you can rewrite it. Okay, net ionic, did anything happen? Yes. We had a solid form, HgCl. How do you make that? What ions are required to make that? Well, mercury plus chloride. And this is going to be aqueous. Aqueous. And what are the spectator ions? Sodium and nitrate. Okay,
That's right, sodium.
Can you do another one of those perhaps? I'm still confused on that as well.
You get.
then
It's just spectator and does it do anything with that?
okay, so I'll do another one here. Let's do
Well, it's heating with a flame, so it's. It would change.
okay. So we have sodium chloride plus silver nitrate. Okay, so this is 2, so that means that is a salt. 2, that means that's a salt. So we're going to do double replacement. That means these two are going to swap. So that means we're going to get sodium nitrate plus silver chloride. So we look up sodium nitrate. It ends up what color? White. That means it doesn't do anything. That's an AQ. And what about silver chloride? It's black. That means that's a solid. Okay? All right, now we need to, that's the molecular equation. Make sure you got all your AQs and S's and all that stuff in there. Now is the net ionic equation. Did something happen? Yes. What happened? We made a solid. And how did we make it? We combined this plus that.
So that's the net ionic part of the equation?
The total ionic?
No, the first one's the molecular and then the next one's the net, that would be the answer.
Yeah, net. Just focus on the word net. What, did anything, just net it out. Yeah. Right. Now, if nothing's made, but in other words, two white boxes, that means null set, nothing happened. That means you're gonna have four spectator ions, not two. Because everything's spectator. Yeah, so spectator ions, well, these guys, spectator ions, because of the AQ. So we have sodium and nitrate. Yeah,
It's the original problem. Switch.
yeah, you have to figure out if anything happens. And that's the job of the molecular.
The spectator. That's the. How did you get that? I didn't see. Spectator.
Oh, it's not Na, it's K. Because it's basically, this up here got moved.
On the test, you want us to show the negative, positive charges,
Yes.
I'm sorry, what?
like K plus, do you want us to show the negative and positive charges?
For spectator ions, yeah.
Does it matter when we put the K?
Does it matter for what? Does it, I still don't understand.
It's two separate, or still like. Yeah.
I guess it's fine. Oh, normally, the positives always go first. But it still works. I mean, particularly when you're putting a compound together, positive always comes first. There's no exceptions on that. When we're just listing ions, it doesn't matter. But I always I'm used to doing positive everything first, so. Oh,
What's the spectator either? The NA plus and NO groups? Yeah. That's spectator. Yeah, because it's not in here, so it'd be the NA.
was that, Misty, was that you asking?
Yeah.
What was the question?
On that one, the two spectator ions, but I got it.
Okay.
There's no NA plus and NO three here. The case on the this one, I asked them to do a separate. I kind of understand it now.
Okay, so let's go on here. All right. So this one here, we've got a metal and a salt. That's single replacement. That means the two metals swap. The lithium goes to the AG becomes where the lithium is. So this is gonna look like this. You need your reactivity table to do this problem. If the metal is higher than the salt metal, it'll go. So the question is, is that higher, lithium? Now, lithium, I know this table is at the very top. So everything is below it. So if you have lithium in there, lithium metal, it's gonna go. So that means we've got silver by itself. Either a zero on the superscript or S. And by the way, AgNO3 2 doesn't exist. This is another reason. So this like that. And if I have an error like that on the test, I'll give you credit for it, so you don't have to worry. Okay, so this is the new reaction. So we've got AQ over here. So yes is the answer. The Y part is lithium is above silver. If it was the opposite, the answer would be no. Why? Because it's below it. Okay? Okay. Draw two Lewis structures.
Some of you did, or did I? That's just the one. I know when I work on the channel for baby, about the elections and I don't think they were here. They were sitting down and saying, whatever, it was definitely here. And I was in 2 more messages. And so teaching one thing to the this, so. And I don't want to know, but that's the way. That's the way I know.
What?
Okay, so that would be one. And this is one I went over in lecture. This is ethanol. You don't need to worry about the name of it, just that this is the structure. Then the next step you do is you put in the lines. Okay, so that's one. This would be the start where you put the two carbons in the middle, everything else around it. But you don't have to always do that. If you've got oxygen in it, you can put oxygen in the middle. And then the two carbons and then surround the outside.
Can you do that? With the oxygens in the middle?
We can do that right now,
Thank you.
because you have to do two structures. That'll be the other one. Okay, 6 hydrogens on either side, oxygen coupling the two carbons together. Okay? And then we're gonna do the lines. Okay, yeah,
Just to confirm, the structure doesn't matter, the correct bond. Like how I set it up, because I did C and then C together, like. Yeah.
Picture of it.
Yeah.
That's just. There's really the same that was aiming on the scenes. And every time it was because I was on the school, I can't.
It's so many years.
all right, how are we doing on this? You need to practice. Okay, what's the formula for the following? Okay, we're on nomenclature now. You need to have your common ion table out, which I gave you. Okay, on the test, as part of the test. It's towards the back 2 pages. Okay, so calcium is +2. Chloride is a -1. So to balance this compound, the charges have to be net zero. So right now, as written, it's not net zero. We need 2 of these. Now it's net zero. So it's going to be calcium chloride. Dihydrogen monoxide. 2 hydrogens. 1 oxide. Also known as H2O.
Professor, one text. So looking at my practice, I just wrote CaCl2. I didn't write the Ca+2. Do I have to write all that out to get my full points? Just the answer?
That part is just so
Because
that,
it's on your chart. You know, just the Ca+2.
yeah, that's the charge of calcium, yeah.
Yeah. So you just want the CaCl2.
Which is,
Yes,
Okay,
so we don't have to show like how we got the CAs.
that's what I wanted.
yeah, that's just for you to,
Yeah, I didn't either. I just wanted to make sure.
Yeah,
Every point counts.
right.
that's right. Okay, name the following. Okay. Sodium hydroxide, chlorine oxide. 5 and 2.
Yeah.
All right, I want you to find these parts on the included periodic table. Yeah,
Like memorize them. They want on your.
right. Like usually we do acids independently.
Okay.
In the workshop I gave you, I said ignore the acids and the H2s. Because those are acids. Do everything else. Okay, so these we need to find on the periodic table. And here is the periodic table. Okay, so you need to know the 4 groups. So this is the halogens. And then noble gases. And there are three more groups. There's the metals. Now the metals, a lot of people miss this. I've been doing this question for decades. A lot of people just say these are the metals here. It includes everything except the non-metals, which are over here. And then what's left over are the metalloids in between the two. And I usually do it like this. Just kind of a blob there. Metalloids. Okay, and I think that's. Yeah. Now, some people, when they put metals, they write all the metals down. You may do that, it's just a lot of work, or you can circle them on the periodic table. I'd recommend the latter.
That's what it's. I just use the halogen.
Halogen is weird. It's both a halogen and a metal. It always puts it on the left, so it's part of the metals, but it acts like a halogen also. Well, the periodic table I give you has an H on the left, but just put it part of the metal. But yes, it is sometimes written in both places. Because it acts like a halogen and also, it only has one electron. So if you lose the electron, then it's a metal. If you gain an electron, then it's halogen.
Yeah.
Okay, so that's it. Now, I'm gonna be here at 3:30 tomorrow. If you'd like to start early, like if you have lab today and not tomorrow, you start the test at 3:30. If you have a combination or you need more time, I'll give you up to 3 hours to do the test. Or if you don't have an accommodation, you still get 3 hours. Okay, so that's it for today.